Logistic regression is used to solve classification type of problems. Their outputs are usually categorical in type, and they give outputs such as true or false or 0 or 1. Here we take an example of whether a mouse is obese or not given its weight. Here weight is an independent variable. Here they plotted the points on a graph, and all these points are, say that the mouse is obese, and these say that the mouse is not obese. The curve usually goes from 0 to 1. So here we are basically checking the probability of a mouse being obese or not obese. So intermediate points like these usually have a probability of about 50%. Now we'll see an example as to why we cannot use linear regression for classification type of problems. Here the points are plotted and an equation is concluded from it. So here, even if the weight is 0, the size can be concluded from the given equation because there is 0.86 y-intercept. However, there is a small problem with logistic regression. The y-axis values are usually confined between values of 0 and 1. To solve this problem, we have come up with a separate function called logit function, which converts the probability into a numerical value. For example, if you take probability of 0.5, its corresponding log of odds value would be 1, would be 0. Similarly, place other probabilities in the given logit function and find the corresponding y values. So when you plot all the points on the graph, the values stretch from -infinity to +infinity. The values reside from the obese values are here in +infinity, the not obese values are in -infinity. Now since the line is formed, we can try to calculate least squares, but we cannot do that in this case because the points are in +infinity and -infinity. So the residuals also will be in +infinity and -infinity. So now we have to convert this line back to the S-shaped curve that we had initially using 0 power minus log of odds by 1 plus 0 minus log of odds value. The probability doesn't change because the probability is not calculated as area under the curve, but instead is the y-axis value. The likelihood that this mouse is 0.9. The total likelihood would be the product of all the likelihoods of all the data points. But most mathematicians prefer log of likelihood. So I just apply all logs to all the values.